Training a model for cats versus dogs. In this section, we will prepare and train a model for predicting cats versus dogs and understand some techniques which increase the accuracy. Most of the image classification problems come into this paradigm. Techniques covered in this section, such as augmentation and transfer learning, are useful for several problems. Preparing the data. For the purpose of classification, we will download the data from Kaggle and store in an appropriate format. Sign up and log in to www.kaggle.com and go to https://www.kaggle.com. See Dogs vs. Cats Data. Download the train zip and test1 zip files from that page. The train zip file contains 25,000 images of pet data. We will use only a portion of the data to train a model. Readers with more computing power, such as the graphics processing unit (GPU), can use more data than suggested. Run the following script to rearrange the images and create the necessary folders. For our experiments, we will use only 1,000 images of cats and dogs. So, copy images 0 to 999 from the downloaded folder to the newly created train folder under cats. Similarly, copy 1000 to 1400 to data test cat 10 to 999 in train dogs and 1000 to 1400 in data test dogs, so that we have 1000 training examples for each class and 400 validation examples for each class. Benchmarking with simple CNN. Benchmarking with simple. Let's run the previous simple_CNN model on this dataset and see how it performs. This model's performance will be the basic benchmark against which we judge other techniques. We will define a few variables for data loading and training, as shown here. This constant is used for the techniques discussed in this section of training a model for predicting cats and dogs. Here, we're using 2,800 images to train and test, which is reasonable for a personal computer's RAM. But this is not sustainable for bigger datasets. It's better if we load only a batch of images at a time for training and testing. For this purpose, a TF-Keras has a class called ImageDataGenerator that reads images whenever necessary. It is assumed that a simple_CNN model is imported from the previous section. The following is an example of using a generator for loading the images. This definition also rescales the images. Next, we can read the images from the directory using the flow_from_directory method as follows. The directory to load the images, size of batches and target size for the images are passed as an argument. This method performs the rescaling and passes the data in batches for fitting the model. This generator can be directly used for fitting the model. The method fit_generator of the model can be used as follows. This model fits the data from the generator of the number of epochs is defined from training, and validation data is passed for getting the performance of the model over training. This fit_generator enables parallel processing of data and model training. The CPU performs the rescaling while the GPU can perform the model training. This gives the high efficiency of computing resources. After 50 epochs, this model should give an accuracy of 60%. Next, we will see how to augment the dataset to get an improved performance.